Here we go. This is the last section in chapter 1, and chapter 1 has been all about what? Quadratics and solving quadratics. Tell me some ways that we have solved quadratics in chapter 1. Okay, that's graphing. Completing the square, solved. Factor and solve. Imaginary numbers going sad map, right, to get x by itself. And so all these things we've done in order to solve for x. But the question is, what if the problem doesn't lend itself to any of these? Complete the square is, just nasty. It doesn't look like it'll work. It won't factor. It's hard to graph and find the intercepts. There's a solution for that, okay? There's a formula that we can use to solve for x when it seems impossible to solve for x, okay? It always works, but it is a nasty formula. All right, and you're going to memorize it. This is what your video will be about. All right, so let me give it to you. You'll notice, remember, standard form of a quadratic is ax squared plus bx plus c. That's where the a, the b, and the c in the formula are coming from, okay? And if you were to actually, if you took this and you completed the square with the variables in there, you would get the quadratic formula. Okay? It's super cool. I'll show you if you're interested at some point. I love it. It's fun. Okay, but anyway, here's the key. Your equation must equal 0 before you start. Must. If it doesn't, make it equal 0. And so we do opposite b plus or minus the square root of b squared, not done yet, minus 4 times a times c, still not done. This is one big fraction, and it all goes over 2 times a. You could have seen this before, yes. Yeah. So when I was in school, the teacher that I had, it does because it looks so involved. She sang us a song, and she'd sing it every time we did it. And so I started out doing that, and then I got to where I make y'all make the songs, and you'll never forget the quadratic formula if you have to make the song, and you have to remember you won't have any trouble. After you work a few of these problems, you'll have the formula down anyway. So let me show you one, okay? And then I want to talk just a minute about one other little part to it, and then we'll jump to the assignment. So let's say I have 4x squared plus 4x plus 1 equals 75. And I have to solve that. And so it says to solve by quadratic formula, so I'm going to use it. But you know, if you were to divide everything by 4 whenever you start, you're already getting into blah, right? All right. So the first thing I need to do is make it equal 0, right? All right, so 4x squared plus 4x minus 74, yuck, equals 0. Okay? To solve this, I just need to plug in a, b, and c. So before I put, that's exactly right. What's a? 4. What's b?
4.
What's c? That's right. It is literally plug and chug. Like, this should not be hard for you if you've got the formula. Opposite b plus or minus. Notice I keep saying opposite. It's just like when we were doing a vertex. If it starts out negative, it's going to be positive. If it starts out positive, it's going to be negative. So it's opposite. B squared minus 4 times A times C. And everybody goes over 2 times A. Okay. It's not just the radical that's over the 2A. It's the entire thing, yes. Everything gets divided by 2a. So the part where most students mess up here is the order that you simplify this. All right, so work under the radical first, because radicals group things together just like parentheses do, right? So if I work under that first, I get negative 4 plus or minus the square root. 16 minus, what's 4 times negative 74? 1,108.
And then 1,108.
Oh. Are you adding them now? Is that what you're putting them together? Or I wrote it wrong to start with. Okay, 1,184. Okay, yes. Yeah. All right, so now it's minus a negative, which would give me a positive. Yeah, yuck is right. All right, -4 plus or minus square root. What is 16 plus 1184? Okay, so at this point, I want to look at that radical and say, can I simplify it? I know I definitely can simplify it some. What's a perfect square that you can take out of there? Let's come over to the side. Square root of 1,200. I know 100 will come out, and square root of 100 is 10, but I'm going to say something bigger could come out since 12 could also be broke down. 400. 400 is going to come out. If you didn't get that initially, that's okay, because what would happen, and I'll show you what would happen. Square root of 400 is 20, right? Let's say you looked at it and you did the 100 first. 112. So you got 10 root 12. Well, you would just keep going. It would just take you more steps to get there if you don't pick the biggest. So then you have 10, 4 and 3, and you come back to the same thing. All right, so I've done all that work just to replace this. Am I going too fast? Are y'all following me? Okay. This is really more simplification than order of operations than it is anything else. 20 root 3 over 8. Wow, sounds promising. So now, what you can do, you can't divide anything under this radical, right? But I can look at all three of these coefficients here like this, and if there's something I can divide them by, then I can simplify this sum. 4.
Oh, that's 20 now.
And you can leave it just like that. Okay. That's the answer. That's what x equals. That's still two answers, right? It's plus 5 root 3 and minus 5 root 3, so it gives me the two solutions. Now, of course, some of them are going to come out as perfect squares, and at that point, you could split the fraction up if they were whole numbers. In other words, are y'all knowing that? Okay. In other words, if you went through the whole quadratic formula and you got something like this, then you could split this up as 1 plus 5 over 7 and 1 minus 5 over 7, which would be, well, if it's a whole number, I'd like you to split it up. But if it's a radical or anything, you can leave it. You've already learned how to graph it. This is, yeah, it's in standard form. These are just the intercepts. These are where it's crossing the x-axis. So you've technically already graphed it. Yeah. Yep. One more thing to tell you about quadratic formula. Oh, no wonder that didn't look right. I just pulled that problem from the completely square section. I was like, God, they're giving y'all really difficult problems for quadratic formula, but we'll do them. Yeah, that's... The other... Golly. One other thing I want to tell you about this, and that's sometimes we don't need to know the whole answer. We just need, you know how sometimes we looked at the standard form equation and we talked about up, down, bend, skinny, wide, y-intercept. So sometimes we just want to do some analyzing without actually graphing or without actually solving the whole thing. So what we can do is this little piece of the formula we call the discriminant. It's a big word that I don't know why we give things such big fancy words that don't really need them. But okay, so what's under the square root? Okay? It tells us some things about the graph, okay? So I have 3 different scenarios that can happen under that square root, okay? I could get 0 under the square root. I could get a positive number under the square root. And I could get a negative number under the square root. Those are my 3, that's the only 3 types of numbers I can get under that radical, right? So I want you to think about something. If you get, and I'm going to start from the bottom and go up. If you get a negative number under the radical, what type of solutions do you get? Negative under the radical gives you what kind of solution? Okay, if I'm under a radical and I have a negative number, I get imaginary numbers, right? So if I have, let's say, the square root of negative 5 or whatever it is, or 24, it doesn't matter, then the plus or minus is still there, right? But it becomes imaginary. So if you get if you do b squared minus 4c and get a negative number, that tells me I'm going to have 2 imaginary solutions. Remember, that means it doesn't have any x-intercepts on an xy plane. So maybe it sits up above like this or down below. Okay, it just never crosses. If you get a positive number, what kind of solutions do you have? 2 regular, I'm going to call them real solutions, real number solutions. That means it crosses 2 different places on that x-axis. It has 2 real solutions there. But what happens if you get the square root of 0? Close, you're close. Remember, so now I would have negative b plus or minus the square root of 0 over 2a.
It just cancels out.
1. It would just have 1 solution, 1 real solution, because this is gone, right? That's that parabola. That is that parabola whose vertex actually sits on the x-axis. Okay? So those are 3 scenarios. So part of your homework will say, consider the following quadratic. Use the discriminant to determine the number and type of solutions. So all I'm doing, and we'll do one together. Let me get one from the right section. Again, we still have to have it equal 0 because I'm still using the quadratic formula. And before you can use any part of the quadratic formula, it's got to equal 0. So I'm going to move, and just because I'm in the habit, I'm going to move this one over here and keep my leading coefficient positive. Okay. So I have 9x squared minus 7x is 2x squared plus 2x. And then when I move the 5 over, I get plus 5. Does that confuse anybody? If you moved them the other way, it's, yeah. If you move them the other way, it's not wrong. I just like my leading coefficient to be positive. All right. Use the discriminant to determine the type and number of solutions. So, but you only have to plug it in to that part, to the discriminant. So, and you don't even have to work it out fully. You can do it just enough until you see, is this going to yield a positive number, a negative number, or 0? So 2 squared minus 4 times 2 times 5. That's going to give me a negative number, right? And a negative number means this will have 2 imaginary solutions. Does that make sense? That's it. That's it for discriminant. So tonight what you'll be doing